Hello, bonjour, viewers. Our good friend, Ms. Tom Hafer, is going to present the topic about climate change. We had a lot of discussions about this topic, but today, Ms. Hafer may bring something you never heard of. So if it's validated in future, we probably the first one to report it. Hello, good afternoon, Mr. Hafer.
Good afternoon, Dr. Liu. We're going to have the third in our series of climate change talks. We started with the question in session 1 of everybody talks about the weather, but nobody does anything about it. So today we're going to talk about how to do something about the weather. So today we're going to talk about a new approach, global shading, which is how to reverse global warming while you're still alive. This is the MIT En-ROADS model, which is a very sophisticated model, but with a simple interface that you can use to see what the effects of different parameters are on climate change. So over here on the left, this graph shows the primary sources of energy under the current set of assumptions. So here's coal usage, oil, gas, renewables, bioenergy, all the way out through the end of the century, the year 2100. And then down here are the parameters that you can play with. So the energy supply, you can incentivize renewables as much as you want. You can disincentivize coal use. Over here, transportation. You can incentivize electrification of vehicles, more electric trucks and buses and cars and various other things. And then here is sort of the important one. You can see what the effect of the current set of policies is on global warming through the end of the century, the year 2100, after probably most of us are dead. So the temperature is projected to rise about 3.3 degrees centigrade versus pre-industrial times. And over here is where we are right now in 2023 at not quite 1.5 degrees. So if we just continue with the current set of policies, it's going to get more than twice as hot as it is right now. So suppose that we do kind of more of what we're doing right now. Suppose that we incentivize renewables as much as we can and incentivize electrification of vehicles as much as we can, and not just us, but the whole world. So what will happen? So we'll slide those slider bars, and what happens looks like this. So we've slid the renewables slider bar to where it's as subsidized as it can be. And same thing with the electrification of vehicles over the whole entire world. And what happens to temperature? Well, this is the part they don't like to tell you. All of those things result in very little difference. Instead of 3.3 degrees temperature rise, you get about 3 degrees. So still more than twice as much as we have now. So if you think that things are bad now, their current policies are just going to make them worse. And it's going to be for the rest of your life. And it's not going to stop then either, because that line is still going up at the end of the century. And it's probably not even going to be that good. Why? Because here are the sources of carbon dioxide emission into the atmosphere. Currently, we have about 37 billion metric tons every year. And the US and the EU, who are leading the way in carbon dioxide reductions, only emit about 8 billion. So there's almost 30 billion metric tons that are being emitted by China, by India, by Russia. And they're not going to reduce carbon dioxide emissions to anything close to the same degree that we are. China has just installed a number of coal power plants, and they're not going to turn around and shutter those. India has now the world's largest population and by far the world's largest poor population. They are not going to hobble their economy, even though they might want to reduce carbon dioxide emissions. And Russia bases its economy on fossil fuel production and sales. and they're a net beneficiary of global warming. So they're not going to stop. So we're going to keep adding carbon dioxide to the atmosphere, and it's going to keep getting warmer every single year if we just do what we're already doing, no matter how much of it we do. So are we doomed? Is there anything that we can do? Well, it turns out that if you can block a few tenths of a percent of sunlight that hits the Earth, you will get noticeable global cooling. And here's an example. In 1991, Mount Pinatubo erupted, and it threw a lot of ash and sulfur dioxide high into the atmosphere. And those particles blocked a few tenths of a percent of the sunlight and resulted in noticeable decreases in temperature during those years. And just to the left of that, you can see the same thing that happened here in the early 80s from Mount St. Helens and El Chichon in Mexico. And then interestingly, during the period of the 40s through about the 80s, when we were pumping lots of carbon dioxide into the atmosphere, but the temperature wasn't going up. Why was that during this period? It's because during those times when we were producing a lot of carbon dioxide, those industries were also dirty, and they emitted a lot of soot. And the soot had the same effect of blocking the sunlight. And so the temperature didn't rise. It sort of equaled things out. And it was only when we started cleaning up industry emissions, starting in about 1980, when the temperature suddenly started to go up dramatically. So is there a way that we can do this without polluting the atmosphere? Well, how much do we need to shade things? First of all, that's a good question. If we want to reduce the amount of sunlight hitting the Earth by a tenth of a percent, 1/10 of 1%, what would we need every square mile? Well, this big square represents a square mile, and to shade a tenth of a percent, you would need to have a parasol or some type of blocking device. It's about 190 feet in diameter. So how would you do that? Is there some way that you could put up parasols over the Earth every square mile? Well, maybe so. You'll recall the Chinese spy balloon. That was about 150 feet across. So right neighborhood, almost 190 feet across. So we could make high altitude balloons that would be 190, 200, even more feet across. And they would fly at altitudes between 80,000 and 120,000 feet. So they would be well out of the way of commercial airlines and even military fighter aircraft. So they wouldn't get in anybody's way. So what would they be like? Well, they'd have a tracking device on them. They'd have propulsion and navigation capabilities similar to the Chinese spy balloon in order to be effective in spacing and recovery. They'd fly at 80,000 or more feet, way above aviation altitudes. They'd be hydrogen filled. We've got essentially an unlimited supply of that. They'd be able to descend upon command. An important thing, the shaded area increases as the square of the diameter. So a 300-foot balloon shades more than twice the area of a 200-foot balloon. Now, can we make balloons that big? Well, sure. The Goodyear blimp is about 200 feet long. The Hindenburg, which was made almost 100 years ago, was over 800 feet long. So size is not an issue. And then an important thing, they wouldn't produce actual shadows, just areas with a little less sunlight. And that's because their apparent size is much less than the apparent size of the sun. So they would produce an area where it's a little darker, about 15%, which would be much less than, say, a passing cloud overhead. So what would this look like worldwide? So the Earth is about 200 million square miles. So if you put up a constellation of balloons over every square mile, it would look notionally sort of like this. But you don't need them over the high latitudes, like here and here. And if you place the ones in the middle optimally, you could make that about 100 million balloons. So the constellation would look something like this. Now, 100 million, that's still a lot of balloons. So is that too many? Is it ridiculous to assume that we could make that many? Well, no. Worldwide auto production is about 85 million every year. So if we can produce 85 billion cars every year, we can certainly produce 100 billion balloons. The average worldwide cost of an automobile is under $30,000. So balloons are much simpler. So I would assume that we could make balloons for less than $10,000. So if we did, what would be the cost of 100 billion balloons? Well, do the math. It would be $1 trillion compared to the trillions that we're spending on everything else related to climate change. What about launching them? Well, thousands of weather balloons are already launched every day. They go up into the air and then they're designed to pop when they get to high altitude. So they come down somewhere and the debris adds to global pollution. But our balloons would not, because we can command them to descend. So they would land at recovery sites. So here's the cool part. These balloons might not cost anything. They might wind up paying for themselves. You've got a constellation of balloons. You could use it for communications. You could use it to bring broadband to rural America or Africa or other places where it's hard to build out infrastructure. It could replace some of the functions of weather balloons. It could do continuous high altitude air and current monitoring. So what you really have is a constellation of very low cost satellites. So the question is, what could you do with that? So to sum up, the world is going to get hotter for the rest of our lives if we just do the things that we're doing now. Renewable energy, it doesn't matter how much of it you make, it's going to get hotter. Electric vehicles, it doesn't matter how many of them we make and how many regular automobiles we replace, it's going to get hotter. Now, that doesn't mean that those aren't good things. They are good. They're just not a solution to rising global temperatures. Balloon deployment, global shading, buys us time and flexibility. They start working immediately, not 50 years from now. They're environmentally benign, no sulfur particles in the air. They're scalable. You want it colder, put up more balloons. You want it warmer, take down some of the balloons. It's way less expensive. $1 trillion for the entire Earth versus hundreds of trillions that we're going to spend. They're controllable. You can cluster them or disperse them. So if you have a big cloudy area, you can disperse the balloons. You don't need them there. The Earth is already shaded. But if you have an area with a hot spell, you can cluster the balloons over that and mitigate the hot spell. It's reversible. You can bring the balloons down anytime you want if something happens that we haven't foreseen. It's way less impactful on the environment and on your lifestyle. You're not forced to go buy an electric car. You can eat a hamburger without shame. You can take your family for a vacation on a jet airplane. All those things that you're not going to be allowed to do. You can have a gas stove. Potentially, it's even profitable. These are like extremely cheap satellites. We just need to interest some deep pockets investor who wants to bring broadband or some type of service like that around the world, and they'll pay for themselves. In fact, they'll be a profit source. And here's the real thing. What are your other options? You've already seen what happens if we simply continue to build more windmills, build more solar farms, build more electric vehicles. It's going to get unbearably hot. Wouldn't this be worth a try? And as an engineer, you always want to try things out before you go for the whole enchilada. So $10 million would buy 1,000 balloons to test. It's a simple thing to do. This is how science is done. This is climate science. So that's the end of the lecture for today. If you have any questions, let me know.
It sounds very scientific fiction to me. It is promising if every the key character in your presentation is truly committed to reality, but I really doubt the cost of each balloon only $10,000 because like the Chinese spy balloon, I mean the hydrogen is very expensive. Also, the material used to be able to fly at that altitude is also very expensive. So I don't know if that would be a cheap way to generate so many weather balloons.
I'll make you a bet. I will. So weather balloons, for example, including their instrument packages, only cost about $1,000, 1,000, not 10,000. Now they're made differently, but the industry exists. I mean, you've seen all of the balloon launches that take place at balloon festivals. I mean, those balloons are not quite the same size as we're talking about, but they would be similar. Now, hydrogen is cheap. I think you're thinking of helium. Helium can be somewhat expensive, and we only have a limited supply of it. But hydrogen can be gotten extremely cheaply by electrolyzing water. We have essentially an infinite amount of hydrogen, and we're trying to build a hydrogen economy. So there are going to be sources of hydrogen available around the world that should not be expensive. And if for some reason hydrogen turns out to be not as desirable as I think it is, we can use helium.
Once you spread those weather balloons, that's 100 million over the Earth, above the Earth. I mean, about the sovereignty of each country's space, is that a problem for them? Do they share those kind of places?
That might be a problem. In some cases, it might be a feature, not a bug. For example, I would love to have North Korea use $1 million missiles to shoot down $10,000 balloons. They can do that as much as they want. But yes, we would require some kind of an agreement by the impacted nations, but it's not that different from airplanes that fly over different nations. It's not that different from the argument that was had in the early days about satellites flying over nations. So yes, we'd have to come to some kind of an agreement because countries might suspect, for example, that you were using the balloons for spying purposes. So probably what you would wind up doing is having some type of an international agency from the UN certify that the packages that are going up on the balloon do not include any undesired capabilities, whatever those might be.
Exactly. It still requires international cooperations, and that's something not so easy in today. The so-called green energy revolution is not going to work. But how do we convince those policy makers and or even educate the public to believe that? I think that's the very first step we have to achieve. Then think about alternative choices.
You are exactly right. The public has been, I'm going to say, misled into a general misunderstanding that if we just cut back on our carbon dioxide emissions, that somehow that's going to solve global warming. It is not. It's a good thing to do for the far distant future. It's good to not have to be reliant on fossil fuels and on things that put more carbon dioxide into the atmosphere. But the reality is that various nations are going to be putting lots more carbon dioxide into the atmosphere for the next century and more, and it's going to get hotter and hotter and hotter. And the climate lobby does not like to talk about that. And I think that in perhaps as little as a few years, if we just have a few more summers and floods like the ones that we just had, that people are going to realize that what we're doing isn't working and that we have to do something else. And that the something else is going to probably be kind of like the solution that I've identified. There are other potential ways of doing it. People have talked about using satellites with gigantic solar parasols to block out the sun, but that's going to be much more expensive than using balloons. And they talk about using chemicals just like the volcanoes do, but the chemicals have their own problems. They cause acidification of the oceans and lakes, and they have health hazards as well. So the nations of the world are never going to agree to that. So I don't see how we're going to solve global warming, which we do need to do, without doing something like this solution. And this is a solution that we can implement this. We could, if we had the will to do it, we could start implementing it tomorrow.
Thank you for today, and we look forward to talk to you for the next topic. See you later.